Alright, so in 3.1 we were solving linear systems by graphing, and then we checked the solution that we got to ensure that it was true. So now we're moving into, we're still solving linear systems, but now we're going to do them algebraically. So 3.2, solve linear systems algebraically. Okay, so you may also remember this back from Algebra 1. You learned about combination or elimination and substitution. So the first method is by the substitution. So the substitution method, and I'm going to give these to you in 3 steps. Okay, so step 1, solve one of the equations. For one of its variables. To substitute the expression from step 1 into the other equation. And solve for the variable. Step 3, substitute the value from step 2 into the revised equation from step 1. And solve. Okay, so basically, if I have 2 equations, I want to get one of them so that I either have y equals like 3x plus 2, or so that I have x equals 2y minus 7, okay, something like that. Basically, I want the variable by itself. And then I'm going to take that and I'm going to substitute that in for either x or y, as the case may be, into my second equation. I'm going to solve for the variable that's left over. When I get that value, I'm going to plug it back in, okay, and solve for it. Okay, and you will have to show each of these steps. You don't necessarily have to say step 1. You don't have to like write on your paper step 1, blah, blah, blah. But I need to see each of those steps as you go when I'm checking your work. Okay, so that's the substitution method, and obviously we're going to do examples of this in class. I just want to run through them before, since you've technically still seen these before. But then we have the elimination method. Okay, another name for it is combinations, or the combination method. I use those words interchangeably, so if you hear one, not the other, something like that, just know they both mean the same thing. These steps are slightly longer than the steps above, but there's still just 3 of them. So first, we multiply one or both equations by a constant to obtain coefficients that differ only in sign for one of the variables. Two, we want to add, okay, or subtract. I'm just going to always say add because you're going to want to have the signs being opposite. That's the way I teach it. So add the revised equations from step 1, combining like terms, we'll eliminate one of the variables. Solve for the remaining variable. And the last step of this one is to substitute the value obtained in step 2, okay, for one of the variables, into either of the original, okay, so not those modified ones, the original equations, and solve for the other variable. Okay, so we still have the ability to have one solution, no solution, or infinitely many solutions, but basically, how do you know which one you have? So when I solve the systems, okay, if I get something such as for no solution, basically you're going to get a false statement for an answer. Okay, when you, basically your variables are going to cancel out, you're going to get a false statement that gives you something like 12 is equal to 8. Okay, not true, therefore no solution. Okay, and we'll do examples of these obviously in class, but just so you've kind of seen it and understand where this is coming from. If you have something like, well, here, infinitely many solutions is basically going to give a statement that's always true. Okay, so example, 0 is equal to 0, 3 is equal to 3, etc. Okay, that's always true. Therefore, infinitely many solutions. Also, sorry, I should have... This 3-dot thing that's in the shape of a triangle means therefore. So if you see that, I use that a lot. That's what that means. Okay, so infinitely many solutions is always a true statement. No solution is always a false statement, like 12 is equal to 8. That's never true. And that's pretty much all for that. Obviously, we'll do the examples in class, and I will try to make sure I hit on an example dealing with the no solution and infinitely many solution, presuming they're not all odd problems. But I think we should have some. Also, just so you hear this now, and I'll reiterate this in class, but if it specifically says you have to use one method or the other, you have to use the method it says. Sometimes I will specify for you on a quiz or a test which one you have to use. But in a homework section that just says to solve using any algebraic method, as long as you use an algebraic method of your choosing, it will be fine. So just make sure you pay attention to the directions for those.